Welcome to the presentation this afternoon. I'm Gary Benton, and today it's my privilege to welcome and introduce our speaker. 2.5 years ago, my wife Tammy ordered Dr. Campbell's book, The China Study. We both read it, and we were so impressed by that book that we've read hundreds of books on health over the years, and this one went right to the top of our charts. You'll get a taste, if you haven't read it yet, you'll get a taste of the information that Dr. Campbell is going to be bringing. Colin Campbell began his life on a dairy farm in the Midwest, and from what I've heard, from about age 5, he started milking cows and working on the farm. As a young man, he studied at Cornell University and MIT in the areas of nutrition, biochemistry, and toxicology. He worked for a few years in the Philippines trying to end malnutrition and hunger among the children there. And then one of his major next steps was to work in China on the most comprehensive study of nutrition that's ever been carried out, and which is known today as the China Study. The China Study book explains in an easily understandable way the impressive amount of evidence in favor of a lifestyle that has the power to save us from the perfect storm. During his career as a researcher, some of the things Dr. Campbell has discovered went directly against what the scientific community accepted as obvious fact. Friends and fellow scientists told him there must be a mistake, don't worry about these things, just sweep them under the rug, don't rock the boat. Dr. Campbell has sought out the truth and has told us the truth in spite of the consequences. Our nation and many of us as individuals are heading toward the perfect storm of a crisis in health and economics that could be disastrous. Dr. Campbell has earned my highest admiration because he has told the truth, regardless of the consequences, in order to help us to know how to avoid the perfect storm. Dr. Campbell has been called the Einstein of nutrition. He has spoken at Loma Linda University, Portland Adventist Medical Center, the Coronary Health Intervention Project, CHIP Summit, and now it is my distinct privilege to welcome Dr. Campbell to our community. Let's give a warm welcome to Dr. Colin Campbell.
Thank you, Gary. That is one of the warmest, most heartfelt introductions I've had. And I've had many during the last couple of years. I really feel at home. My wife and I have been here just a short time. And as Gary explained to you, we come from an area in upstate New York that some of you may know had you been there. That is not too different from this. Rolling hills, perhaps a little more, but in any case, countryside. I'm a countryside person, I'm a small town person, and so I feel very much at home here in College Place in the Walla Walla County or Valley, I guess you call it. It's my first time here, so it's very nice. I want to thank Gary for making this opportunity available to come and speak to you. And because in a sense, I've really become quite passionate about what I have come to believe. I'm supposed to be a scientist and be very objective and all that. But I've really personally, as well as professionally, have come to really have a lot of confidence in what this message is all about. And it's my delight, actually, to share it with you. Just the sum and substance of this, really, is that a diet properly constituted and used really has an amazing ability to create health, recreate health, prevent disease. It's really far beyond what, in fact, I thought when I first started my career. In fact, I would suggest for you thinking that nutrition as a topic, as a discipline, really ought to be the premier biomedical science. It's not. But at least for the future, I would like to have it considered that nutrition, if it's properly understood and practiced and used and professed and taught, really ought to be the, as I say, the premier biomedical science of the future. It's a complicated topic. Nutrition is confusing for a lot of people, as you know. I think, what do we have, 300 million people? I think sometimes we have 300 million different views of what nutrition is. I mean, there's a lot of confusion about nutrition. And I'm going to speak to this question a bit and share with you in this lecture and two more, incidentally, are coming up tomorrow, some ideas that, to me, even though nutrition as a biological science is very complex, nonetheless, we can actually sort of see this elephant in the room, and we can get a feel for it. We can know what it can do. Now, it's just a question of, and it's not that difficult. It's not that difficult. I'm really confident that if it's told properly, and if people use it as it's meant to be used, and to see what it can do, they will become quite convinced it's not that difficult. Now, there's various ways of, I mean, it's actually 51 years ago, this August, that I started my graduate career at Cornell University, starting down this path of working on diet and health. It's been quite a long time. And I've been graced with a lot of excellent students, colleagues, professors at different institutions, Cornell University in particular, but elsewhere, outside of the United States. And I really owe them my gratitude for the kind of work that they were able to do to allow me these days to be able to tell the story. And although this topic is, as I said, is biologically complex, and it means that there's various ways of telling it without getting too confused. And so when my son, our son, Tom, our youngest son, joined me to do the book, he incidentally had been a graduate in theater at Cornell University and was an aspiring actor in Chicago, doing well. Good communicator, came back home, worked with me for 3 years, excellent writer. And so we together actually wrote this book, and he made the readability of the book very much possible, together with my wife's critique and review of the manuscript as we went forward. But in any case, on the question of how to tell the story, there's various ways of doing it, because it is a big story. It has more to do than just with the food you decide to put in your mouth. It has many consequences. It has many consequences for us personally. It has many consequences for our family, of course, and our friends. It has many consequences indeed for our environment. It has many consequences for our society. And Gary, of course, alluded to that. There is a perfect storm. The perfect storm has started. And so let me get started then and just share with you first the different kinds of things. Let's give you a little hint of how sometimes difficult it is to tell the story, to tell a simple story that really is quite complex. But in any case, let's have a first slide here and see what we can get. I mean, following that statement, I think I forgot to finish the sentence before. My passion is that it's all about consuming plant-based foods. Vegetables, fruits, grains, legumes. And consuming in their whole form, not taking the stuff out of them like sugar and white flour and oil. That doesn't quite do it. I'm talking about whole foods and good quality whole foods. Now, as far as telling the story is concerned, a lot of it for me centers on something that really has been kind of hidden from view, I would suggest, not necessarily intentionally, but it's a story that hasn't really been well understood and certainly not told. And it has to do with our reverence for protein. If you think of all the nutrients present in food, there's one nutrient that seems to stand out tall. People worry as if, in fact, they change their diets. They worry about where they're going to get their protein from. Protein is, I would argue, has been kind of ignored, except for advocating its great properties of creating health. It's kind of been ignored. And our assumptions that we've made about protein have, in fact, historically driven greatly the kind of dietary practices we have, and has driven greatly the kind of science we practice, and has driven greatly the kind of medicine, in fact, we practice too. When I was growing up at the farm, to the extent I even heard the word nutrition or anything about it, and milking cows, I knew, I think, for one thing, that cow's milk was the nearest thing as the food from heaven that you could get. And it was valuable because of its content of protein. It was this high quality protein that was so important. It's one of the things that was actually said about dairy, you know, you must consider good protein. That's not quite the way it should be. That became the early part of my career and consumed much of my interest for much of my career, and I'm going to tell you why I think that's not quite true. Naked reductionism. This says something about science. It says something about the practice of medicine. Reductionism means looking at the trees instead of the forest. That's really what it is. And it means, in fact, not just looking at the trees, it means studying the trees in great detail, with great depth. And that's really what science tends to do. It tends to study individual nutrients or individual diseases or individual so-called mechanisms of action in isolation of the rest of the whole. And we do it well in science. It's a lot of fun. But what we don't do well is to sit back and look, you know, at this massive amount of information and try to draw from that, what is it really telling us? Is there a forest here? And so I get concerned, in fact, both in the practice and the art of doing scientific research as well as in practice of medicine. I get concerned with the fact that we are too reductionists, and therein lies much of the confusion. Because when we study things in isolation, we can often show opposite effects, contrasting effects if you use different systems. It's a source of great confusion. Policy shenanigans. I spent about 20 years of my career, almost continuously, almost a 20-year period, involved in being a member of a so-called expert panel, involved in writing standards or developing dietary and health policy for our country, for other countries. And I actually was in a place where I saw firsthand the interface between science and policy. The interface where a group of people get together, so-called experts get together and see what is there and then decide to tell the public what they want to tell them. It's not a very pleasant story, to be honest about it, but it certainly is a very important story and something we have to understand. NIH ownership. NIH is the National Institutes of Health. It's a US government agency responsible for conducting and funding biological and medical research in this country in large measure. They fund the majority of the research in this country. And the research that tends to get published in so-called peer-reviewed journals, for the most part, has been funded by NIH and or, in some cases, by organizations like the American Cancer Society, American Heart Association, and so forth. NIH is the agency, the institution that drives much of the thinking as far as the kind of research we tend to do. It's taxpayer money. It's your money. It's your money. And we ought to be using NIH, we ought to be using that kind of funding to look at evidence in a very objective way. And unfortunately, I don't feel that's true. Institutionally, systemically, I have learned that although most of the people are very good people, hardworking, honest people who are working in this discipline, on the one hand, they're somehow missing this, you know, the overarching sort of thing that tends to drive the NIH budget. And that, unfortunately, there's somebody I'm suggesting owns NIH in a sense, and I'm going to say that it's largely the pharmaceutical industry. They get their way in seeing what's developed. And the majority of the public these days tend to think that drugs is the primary source of health instead of food. I have a different view. Defining nutrition, defining health, defining medicine, important concepts. When I started my career, we were taught something about nutrition. Of course, I did my major field of study for my doctorate was in nutrition. Actually, in those days, and still today, most people do this, they learn about nutrition as to what individual vitamins and minerals and macronutrients do. And as I mentioned before, this is a very reductionist point of view, studying things in isolation like that. My views today are very different. As I indicated earlier, it's more about food. You know, all this stuff working together. It's a big difference, a huge difference. And this in turn translates into some rather different views about what health really is and how we should think about it, how we can restore it. And it really has a lot to do with the practice of medicine, a lot. And I may not say too much in this particular lecture, but in the next two I certainly will get into that. Slimmer wallets really refers to the fact, Gary alluded to it, it really has to do with the fact that we today are spending an awful lot of money to not get much health. Just as a statistic, for example, the United States, their per capita medical care cost in this country is the highest in the world. It's 50% higher than number 2. I mean, we're way out in front. Yet when our medical system, our healthcare system is compared with other countries in the world, using various criteria, we stand somewhere in the neighborhood of 30th to 40th. We're down the list. How can we spend so much money and get so little in return? That's the storm. That's the storm that's beginning to rise. And the cost, in fact, slimming our wallets, is breaking the bank. It's breaking our personal banks, it's breaking our corporate bank. Okay, now to get into my story. As I said, there's so many different ways to tell this. When we were doing the book, we were sort of thinking, well, how do we do this? We have a chapter on protein, a chapter on carbohydrate, a chapter on this, a chapter on that. No, I mean, that was a traditional way of thinking about it. So I didn't know how to do it, really, and we talked about it, my son and I finally said, well, why don't I just tell this story as I learned it? Because obviously, I got to a place in my career where I think something very differently. And why don't I just tell it? You know, this is the stuff that influenced me, right or wrong, and let the reader decide for themselves. And so, as Gary indicated, and as I already said, I started on a farm. And that picture here, an old picture that my mother retrieved, I just show it to you just to make sure that you know I came from the farm. That's me just there by the steering wheel in the front, maybe 5 or 6 years ago, something like that. Then it was off to graduate school at Cornell University, where I did a doctorate in nutrition, a major in nutrition, minors in biochemistry and microbiology. And this is the title of the thesis that I did. And this, incidentally, was taken from the farm into the laboratory, an idea that I sort of held dear. It was basically a project that was designed to try to figure out how to grow animal protein more effectively. Because that was the big thing. That was the big thing. Make sure everybody had enough protein. And this title is a little bit technical, but it refers to a compound called biuret, which is a non-protein nitrogen substance that we were feeding to cattle in order to see if, in fact, these cattle could actually use that kind of material to make protein as they consumed it. So it was, as I said, it's all about protein. And then it was off to the Philippines. My first professorship was at Virginia Tech for 10 years, and while I was there, I was in charge of a nationwide program of feeding malnourished children with my senior colleague, who at the time was the dean of the college. And malnutrition in the third world is a serious problem. It was certainly then, still is. This is, of course, an unfortunate consequence. And when we look at a question concerning how to feed malnourished children, we tend to think in the professions about malnourishment being either due to an inadequate intake of calories, just simply not enough food, or inadequate intake of protein. Not enough calories means a condition called marasmus. Not enough protein means a condition called kwashiorkor. And so the question concerning inadequate intake of protein, that was my calling in a sense. It was, you know, let's make sure these kids get enough protein. And we therefore worked on that project in the Philippines in large measure to try to assure that there was an adequate consumption of protein by these kids. In average in the Philippines, they were only consuming about 75% as much protein as we do. And it was only a small fraction of people who, maybe 1 or 2% of the families, were rich enough to afford, you know, the richer Western diet, higher in protein. And so I was all enthused about, you know, with Dr. Engel, my senior colleague at the time, putting together a program to get more protein into them. But then one day when I was playing golf, which I like to do, with the medical advisor to the president of the Philippines, he, being a surgeon, told me about how he and some of his surgeon colleagues had operated on children aged 4 and under for primary liver cancer, a fatal disease. And I had an interest in liver cancer, by the way. I had a general interest in cancer, and particularly in liver cancer. And I knew that that sounded very strange because liver cancer tends to only occur in people middle-aged and older. Children get a liver cancer. It didn't make sense. And then, I didn't, to be honest about it, make too much of it, but certainly heard his comment. Then learned not too long after that it seemed like the children who were most susceptible to getting liver cancer were coming from families who were the best fed. They were the few families who, in fact, were consuming the adequate levels of protein. And all of a sudden, you know, something's going on in my head. Wait a minute. Protein is so important. Why are we going to the Philippines trying to get all these kids to consume the level, up to the level of the few people who, in fact, ran a risk, possibly, of their children getting liver cancer? So that was controversial, to say the least, that protein might have something to do with turning on cancer. And it wasn't published. It was just an observation, just a personal observation. But it was at that time then that this report was published in 1968. An experimental bit of research on experimental animals, rats, done in India, where they were basically examining the effect of protein feeding on liver cancer, a kind of liver cancer that was thought to be rather similar to human liver cancer. And so their hypothesis was that if they fed really good levels of protein, the kind that, you know, we tended to aspire to, like 20% of total calories, that would prevent the cancer from forming. And incidentally, in this particular experimental setting, these animals had been exposed to an experimental carcinogen that causes liver cancer. So they fed the regular levels, the good levels, the healthy levels, and they fed the much lower levels of protein, 5% of calories. The level that's considered not enough, that's not enough. The rats, which incidentally in this case need about the same amount of protein as we do, as humans, both species needing about 10% or so protein diets. When they're fed 5%, that was considered to be enough. And so what did they get? They got the opposite result. The animals fed the higher levels of protein, 20%. You could see that all of the animals got liver cancer in this small study. In contrast, the animals fed to 5%, none did. You don't need a statistician to decide whether or not that's statistically significant. That appeared to me to be real, but even more to the point, it coincided with what I thought I was seeing with children. Higher protein intake being associated with more cancer. So then we came home. I got involved with NIH money, who in fact were very generous with me over the years in funding this research in large measure. It was all published in the very best journals, I must tell you. I have to say that because otherwise people hear this and they say, oh, it's a bunch of quackery. It's not. It was reviewed by my peers in order to get this very competitive funding, and it was also reviewed by my peers when it was published in the very best journals. In any case, we spent the next 27 years with National Institutes of Health funding on this particular project examining this question. And I started out with sort of two questions in a general way. First, I wanted to repeat the study that the Indian people had done. I mean, maybe it's wrong. So we just wanted to demonstrate, confirm it. The second thing we wanted to do, and we do this in science, we wanted to figure out, how does it work? If we know how it works, if we know what the mechanism is, as we say, we get more confidence in understanding that it's for real. So we started out the study, and I'm going to show you just a couple of charts here that illustrate some of the more essential features of our finding. This is a display showing the development of early cancer in rats as a function of feeding either 20 or 5% protein diets. 20% the good level, 5% the inadequate level. Over the first 12 weeks, we had ways of actually being able to see, measure cancer develop in its very early stages. And you can see 20% just really grows these cancers like gangbusters, straight off over the first 12 weeks. The 5% did not. So at this point, I said, wow, I think we confirmed what the Indian workers observed. I think we also confirmed what, in fact, I thought I was seeing in these children. But then the next part of the study was kind of interesting. We did this in many different ways, just as this one little sample. Namely, we wanted to ask this question: what happens as these tumors start to grow? And you change the level of protein intake, for example, a nutrient, a good old nutrient. By the way, protein is an essential nutrient. We have to have protein, up to about 10%, by the way. We need about 10% or so. But in any case, protein is. What happens if we sort of intervene along this process? And let's say give them 20%, the higher level, for the first 3 weeks. You can see these cancers are forming as expected. And so then we turn around and give them 5%. Switch them. We turn off the cancer. We put back the higher protein back again, and we turn it on, and then turn it off. In other words, what we were demonstrating here was that we could turn on and turn off tumor development, cancer development, just by feeding protein at these higher levels or taking it away. Now, one of the questions I'm sure you must have right now, and I'll come back to this in a moment, it's worth repeating a few times. The question is,